We got my notes in my backpack from last night too, but I'll grab those.
You have to give me a permit. All right, today we are working with congruent triangles. And the good news is, the six corresponding parts that we had to get congruent in the proof yesterday, we can get by with less when there are triangles. But we have to figure out which combinations of sides and angles do work and make sure that we get the correct arrangement of them. So we're going to see which ones work. I'm going to have you do some creating of a few triangles to discover which ones do work and which ones don't. So we're going to try our first experiment that is based upon triangle rigidity. It says that if the three side lengths of a triangle are given, the triangle can have only one shape. We're going to try that and see if we agree with it. I want you to create a triangle using whatever tools help with 2-inch side, a 3-inch side, and a 4-inch side. The triangle rigidity says that if everybody makes a triangle with those same three sides, we will all have the same triangle. We're going to see if it really works. So measure with your ruler specifically. You can use compass if that's going to help you. You need to form a triangle that has a 2-inch side, a 3-inch side, and a 4-inch side. Side, a 3-inch side, and a 4-inch Anyone having trouble getting it put together?
Yes.
So that did end up 2 inches, 3 inches? Okay, that's not right then. This is easier done with a compass and straight edge because you don't really know how far to put the sides apart, right? You might try it and you lucked out, I think, unless you plan ahead. But knowing exactly how far apart to put them is tough. So start with one of the segments, and I usually start with the longest one. And I'm not going to actually measure up here, so mine's probably not going to look like yours. But measure, I'll try to make it reasonable. Measure a 4-inch segment, and then use your compass. Because you know there has to be like a 2-inch on one end and a 3-inch on the other, but I don't know exactly what angle to put them at. So set your compass, using your ruler to help you, set it out like 2 inches. Set it at 2 inches, and on one end, make an arc. Somewhere along here, the triangle's going to connect, and that's a 2-inch segment from this end. And then I'm going to go 3 inches from the right hand end, in my case, where they cross, and with your straight edge, of course, but this would be my 2-inch, and this one would be my 3-inch. So that would be a triangle with 2 inches, 3 inches, 4 inches. Okay, now I hope not everyone did that on the marker board, a few of you did, because what I want to do is have you compare your triangle with a neighbor. And in order to see that they're the same, you need to really take the papers and lay one on top of the other and maybe even look through to the light to see if they are congruent. So check to see who's done around you and see if you can flip your papers and put one on top of the other. Are they identical? If they're backwards, are they the same triangle? Yes, they're just rotated differently. So we're kind of, that's not a legal construction. Okay, so what I did was, this wouldn't be considered just a construction because I measured along the way, but I just made my 4-inch segment. I just drew it with my ruler. Okay, then what I did when I went over to my ruler here, I'm opening my compass so that the point is at 0 and the pencil is at 2 inches. I'm setting it at a specific measurement because that's how I presented the problem, I guess. And I marked from one end of this, I marked my 2 inches. Then I changed my compass and set it at 3 inches, and from the right-hand end with 3 inches. When those two cross, then I can finish the triangle. Does that make sense then? Okay. Did we get congruent triangles? Triangle rigidity says if we all use 2 inches, 3 inches, and 4 inches accurately, we'll get the very same triangles. I saw you were comparing, Brendan. Did they match up? You just had to flip it? It's perfect. From what you could see, did yours match exactly? Did you compare yours? Did they match? Just turn differently? Well, you should be able to flip your paper and still get them, still put one on top of the other, just flip it. Let's see, get the 2 inch over here. Okay, did it work?
I did
2, 2, yeah, that's the same. Okay, that triangle should have been identical. If you have all 3 sides of one triangle congruent to all 3 sides of another triangle, those triangles will be identical. They will be congruent. They might be turned differently or flipped differently, but they are congruent. So we will refer to that as side, 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 congruence, and this one's a postulate. I'm going to just abbreviate side, 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 congruence. These only work on triangles. If you are trying to compare 2 4-sided figures, you have to look at all 4 angles and all 4 sides. There are no shortcuts that will guarantee congruence. But on triangles, because you can't make some in a variety of different ways, there are certain arrangements of sides and angles that set the triangle. All 3 sides is one. So for this one, as it says, you're comparing 2 triangles. If 3 sides of one triangle are congruent to 3 sides of another triangle, those 2 triangles are congruent, which means everything about them is the same. Their sides, but then also the matching angles are congruent. And remember that statement at the right hand for the conclusion there. You do have to list those triangles in the order that they match. But it has to be in the matching order. All right, so
that's just the first one. There will be some other ones. We won't explore all of them, but we will do some of them. Let's try some applications of side-side-side congruence. Got your notes? Okay, looks like we're good. So this one says, use side-side-side to explain why triangle ABC is congruent to triangle CDA. That's kind of an informal way of saying prove it. So can you get all three pairs of sides congruent from one triangle to the other, supported by reasons? And if there's tick marks, it's given. Tina.
AC is, with AC.
Okay. And we were given segment AB congruent to segment DC given. We have segment AD congruent to segment BC given. Kanan added segment AC congruent to segment AC, reflexive property. That would be the third side in both triangles. So can you see all three sides marked in each one? And they're the same? So the triangles are congruent by side, side, side. So I mentioned the given, mentioned the reflexive, and the side, side, side. This would be what kind of a proof? Paragraph proof is what that looks like. Okay. Question on that one? Side, side, side's the easiest one to find or to pick out. Okay, here's what you're given. We've got segment AB congruent to segment DB in the picture that was given. So that's one pair of sides. We need to come up with the other two pair if possible. John?
AC is congruent to CD.
AC is congruent to CD. Do you have a support for that?
Definition of
Okay, and where's he getting the midpoint idea? It was given up here. Okay, so think how that would be in a proof. This would be given, and then next line would be definition of a midpoint, saying those two segments that he gave me. What else? Got two sides congruent. Kenneth? Okay, again, that segment is the same in both triangles. And so we do have the triangles congruent by side, side, side. Let's make sure they matched right. Triangle ABC is congruent to triangle DBC. So make sure that it matches the correct order. Okay, that's another side, side, side. Let's try another one. Looks like I didn't have you investigate this one, or at least not yet. Maybe we will after we look at the theorem. Okay, the next postulate is side angle side congruence. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. What's an included angle? An included angle is an angle formed by two adjacent sides of a polygon. Formed by two adjacent sides. So angle A is the included angle with sides AB and AC. E is the included angle with segments EF and EG. Any angle could be an included angle, but you have to look at the whole grouping. What segments are we talking about in relation to which angle? Is the angle made up of those two or included between those two? So this one is, I'll add to my list, side angle side. Congruence. And that's going to be one angle, and the sides make the angle so that the angle is included between the sides. Pictures? I think, let's see. Some of them I skipped just because of time. Let's see if I can do this one or not. Let's try and make a triangle. See if we can get the side angle side to work out. I think we've got time. So you might have to flip to the back of your paper. But on this one, to set up a side angle side, I'm going to give you two side lengths and the measure of the included angle. You might start by drawing the angle. Okay, what have I mentioned? I want a 40-degree angle. So use your straight edge and your protractor. We're not really constructing, we're just making one with the protractor. draw a 40-degree angle. You don't know something. So give yourself a segment to start with. Measure 40 degrees accurately as possible. Once you have your 40-degree angle drawn, then it says use a 2-inch side and a 3-inch side. So make one side of the 40-degree angle 2 inches. Make the other side of the 40-degree angle 3 inches. Then, just close it up to finish the triangle. And compare it to a neighbor. What you might do is see how long's that last side. See if you figure out how long. Is this the current one? All right, how's this one working? Does that look like it is? How long is the other side?
2 inches.
What, 2 inches?
It's a hair.
Like 1
A hair under it? Just a little bit under it? Okay.
It's 10 pounds, 1.9 centimeters. But that's just really.
All right, so that pretty much made an isosceles triangle, I guess. Okay, so it sounds like quite a few are coming up with that last side to be the same length, so then our triangles would be identical. So side angle side is a congruence relationship also. So now the side angle side, the reason that the letters are written in that order is because the angle has to be included between the two sides. So that's a reminder of how the arrangement is. The angle is included between the two side measurements. Okay, so here's an example where we might use side angle side. It says the diagram shows part of the support structure for a tower. Determine if the triangles are congruent. If so, provide a proof and triangle congruence statement. So pretty much what we did before. Can we come up with these two triangles congruent? Okay, segment XZ is congruent to segment VZ. That was given. Segment YZ is congruent to segment WZ. That was given. What else can you come up with support? Angles or segments? There's some angles in this picture that are congruent, and we have a reason. Megan's dying back there. She wants me to call her. She knows it. She knows it. 2 more, 3 more. Okay, got a few more. Nathan? Which angle Z? X, Z, Y, this top one? congruent to this one, WZV. Do you have a reason? Those are not the very same angle. So no, it's not reflexive property, but there is a reason. Abby? Vertical angle theorem. Vertical angles are formed across from each other like that. We did have vertical angle theorem that said vertical angles are congruent. So with that thrown into what was given, notice we have side angle side. We do have the two triangles congruent. So things that we studied earlier, yes, are going to come back up here. Okay, next idea. Segment BC is an angle bisector of angle ABD. The angle on the left is bisected. Determine whether the triangles are congruent. If so, give the reason and the triangle congruent statement. I don't think I did the triangle congruent statement last time. I just clicked it. So we'll talk about that one more this time. Okay, give me some things besides segment AB and segment DB as congruent. What else is in the given, and what's that mean? What's it mean if segment BC is an angle bisector of angle ABD? Megan?
Angle ABC is
What's your reason? Correct. What else? We don't have enough yet. What else can we do? I'm going to try and grab some that don't always put their hands up. What page? Something else? Okay. What else can we come up with in here? Delta? Tristan?
No, I think you got it.
I know. Do you see the two triangles hooked together? Some of you especially that don't have your hands up. Okay, there is a segment that is a side of both triangles. What segment am I talking about? The BC one. Okay, so segment BC of one triangle is congruent to segment BC of the other triangle, this one right here, because of reflexive property of congruence. Did you hear that, Tristan?
Reflective property.
Correct. So where they're hooked together, we've had a lot of that. Reflexive property of congruence applies. Okay, so notice we have an angle and the two sides that make up that angle. So we do have side angle side. I'm going to have you finish the congruent statement for me. If I say triangle ABC is congruent to triangle, how would the other one be listed? Tristan, up here. The other one would be DBC. Correct. So you've got to list them in the matching order. So that was another side angle side congruence relationship. Okay. So little check of understanding with your partner. Which postulate, if any, can be used to prove the triangle's congruent? Problems 1, 2, 3 with your partner. And let's see, this row can pair up differently. Page and
Okay.
First
one.
you're answering what you think with your partner.
So,
Three is side angle side.
yeah, 3, yeah. I feel like 2 would be side, 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 because, yeah, because the same side, so. 1, oh shoot, I lost
Okay, number 1,
I don't know.
postulate, if any, that could be used. Is it side angle side?
Yeah,
Where's the angle that's congruent?
it's the upper right or the bottom.
The upper right? Why, what's your support? Why is that one congruent to, which other one did you want?
Bottom right.
Bottom right? Why are those congruent? What's your support? Maybe that's not what you did. Okay, if you're using these and thinking alternate interior angles, I'd ask, are the lines parallel, so you can use that theorem? No. Okay, you want a different angle, you want it up here?
Yeah, that's what I said.
Do you have support why those two are congruent? That's not a definition or a theorem or a postulate or anything. Okay, so you want to change vertical angles? Do we have a vertical angle theorem?
I think, yeah.
We do.
Yes, so that's one that can be supported. This angle is congruent to this one, vertical angle theorem, but it's not side angle side. Correct. They're not congruent. They kind of look like they're the same, but we really don't know anything about how long this side is or what that angle is. Might be open a little bit wider than the other one. So there isn't enough there to be sure that they're congruent. Okay, so that one was not congruent.
So for it to be side angle side, you have to have like the angle.
The angle has to be included between the two sides. Yes. So what John wanted to mark would be where you need it, but we didn't have any support why those angles would be congruent. Okay, number 2, what'd your group come up with? Side, 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 once you do the reflexive property, correct. How about 3? Look again. None, because they don't match right.
We were.
Tricky. Vertical angles, yes, you could use that, but still the sides and the angles are in different places.
I'm wrong in this too.
So they have to match up in order to work. Okay, let's go to a couple more. I think I'm gonna skip this investigation so that we can make sure we get through them. Okay, this one is angle, side, angle. Now instead of 2 sides, we have 2 angles. If 2 sides and 2 angles and the included side are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So what's an included side? An included side is the common side of 2 consecutive angles in a polygon. So if you are looking at, in the picture, angle A and angle C, the included side would be segment AC. That side is included between those 2 angles. In other words, it hooks those 2 angle vertices together. So angle, side, angle is going to have 2 angles that are congruent, and the side that's between them is congruent. The included side. Got your pictures? Anyone still need this screen? That definition is maybe just above that theorem. Included side is the common side of 2 consecutive angles. Again, any side could be called an included side, but it has to be paired with the correct angles. The angles have to be on the ends of it. All right. Can we use angle, side angle to prove these triangles congruent? I'm going to pull the triangles apart because I think it might be easier to see. We've got this angle congruent to this one that was given. And if these are both right angles, are right angles congruent? Yes, we have the right angle congruence theorem. Okay. And the 2 triangles are hooked together. So what can we use to support this segment being the same in both triangles? Reflexive property of congruence. Okay, is this angle side angle? The side hooking the 2 angles together? Okay, yes, it is. So I think we explained as we talked through that one. All right, how about this picture? Can we use angle side angle on this one? angles, sides. Can we support a side? Because that last one we didn't have a side, but we came up with it. Can we come up with a side that's congruent? And why? This one you don't have a reason for a why. So cannot do that. They have to maybe be hooked together so we could do reflexive or something. Okay, how about this one that has a parallel? And again, I'm going to pull the triangles apart while you're thinking. You need to be thinking. Okay, parallel lines, what can we do with that? If they're parallel, are they the same length? Does parallel mean congruent? Okay, no. Just because they're parallel doesn't mean they're congruent. So I can't switch those to tick marks, no. Are there any segments that are congruent? Okay, John?
NL is equal to NL.
Correct. And that would be those two. I should probably label these. All right, so we've got that. Are there any other segments we can support congruent? No. Okay, guys, you're distracting me. Okay, can we get any angles congruent? Parallel lines, can you come up with angles? When we had parallel lines in a transversal, there were certain angles that would be congruent. So concentrate on this line and this one being parallel. Maybe the diagonal as the transversal. Can you focus on the blue and tell me what angles are congruent? It is a big Z. The corners of the Z are what kind of angles? Alternate interior. So we should be able to get this angle, KLN, congruent to MNL. Are they 45 degrees? Is that what you asked?
Yeah.
Don't have to be. They could be 40 and 40. Okay, if we use a different transversal, some of the angles are outside. M what? MLN, like this one? NML. So this one, what transversal would you be using? If you're using the one I've highlighted, notice that doesn't even form angle M. If you took out this side, just kept the blue, angle M wouldn't even be there. This is as far as we can get on this problem. The other sides are not parallel, so we can't do alternate interior angles the other way. So we only get one pair of sides and one pair of angles in this diagram. Okay? Now the next diagram, I have taken the same thing and added the parallels going the other way. So remember we had this and this. Now that we have parallels also going the other way, I can do parallel lines and transversal. Now this angle can be congruent to this one by alternate interior angles. Now if you can focus on each triangle separately, don't we have that in one triangle and that in the other? Angle, side angle. But we needed both parallels in order to do that. All right, I think we've got angle, side angle. Let's try angle, angle, side. Still two angles and a side, but where that side is positioned differently makes it different. Where's the angle this time? Two angles and a non-included side. The non-included side is not going to be between the two angles. So it's like on the end. Angle, angle, side. Two triangles. My triangles are getting bigger every time I'm doing notes on the board. Okay, still two angles. But the side is not hooking those two angles together. It still has to be in the matching spot, but not hooking the two triangles or angles together. So if my side was this one in the other triangle, it can't be the bottom one. It has to still be that matching one. It has to be beside the same angle. Because if it were down here, Notice that it's beside the double angle marking in that triangle, and it's between the single angle marking up here. That's not in matching spots. If I put them both on the bottom like that,
Yeah, but that's not.
that would be angle side. Yes, they're in matching spots. So the arrangements have to be the same, but just the sides not between the two angles. Okay? So we'll go back to some of these pictures, can we use angle side in this one? Is it helping when I draw the triangles separate? For some of you, I'm sure it is. Especially at the beginning, that helps if they're hooked together. So that's what we've got so far. Can we come up with any sides congruent? And support? Riley, do you have the idea on what you could do with the side? When the two triangles are hooked together, this side is the same in both. So what supports why that is the same segment here and here? Like why would AB be congruent to AB, for instance? No, not segment bisector. Dalton, do you know what it is? Reflexive property of congruence. Okay? When it's hooked together, because this would be the same segment AB congruent to segment AB. All right, do we have angle side in the information? Yes, notice it's two angles and the side is not hooking them together, it's not included, it is non-included. So that is our, yes, angle side. You're gonna have a worksheet with a lot of pictures on it, and you're trying to come up with what method of congruence, if any. Angle side for this one. We had this very same picture just a little bit ago, right? Angle, the right angles you said were congruent. What property, Riley? Reflexive property. Angle side? No, but we can, yeah, it is angle side angle. We can actually turn it into angle side if we wanted to. How? You see two triangles. There's two angles congruent in both triangles, right? There's a theorem that said if you have two triangles and two angles of one triangle are congruent to two in the other, then the third angles are congruent. Third angles theorem could be used in this example if we really wanted to. Well, then third angles theorem would support this angle congruent to this one. So now if I want angle side, let's just ignore one of the angles. Let's say forget that one. If we focus on those two angles inside, it is an angle side. So it depends which parts you're using. If we were doing a proof, would I take the time to change it from angle side angle to angle side? No, I would do the easiest one. But it is possible to do that type of thing. Okay, and this picture. What did we come up with? It's got one pair of parallels. That gave us these alternate interior angles. This reflexive. Can we get more? Can I? This one? Why? If I had parallels on those two sides. The next screen is going to have both. But the one that we're on, oops, only has one of them. So no, can't use the other alternate interiors. We still get stuck on this one. Still can't do anything more. So let's add that second parallel that Kenna wants. So we've got those angles. Then we can do these also. Is that angle side? Pull it apart. This. Is that angle side? No, it's angle, side angle. Okay, you mean, are you trying to use this as given? I think you are. I think you're trying to use that as given rather than as the conclusion. So that's not exactly what we did yesterday. Okay, on this one, you could use the third angles theorem again and turn it into an angle side if you want it.
So like,
Well, which one do you want to forget about? Maybe the double? Yeah, you could do that. If someone else wanted to forget about the single one, they could to make it angle side. If you forgot about this one with the slash through it, it would be angle side. It would be angle side angle. It still works, but it's not the method that I've mentioned. I think you did that. All right, some of you are kind of burnt out looking at pictures, huh? Okay, what's the difference between angle side angle and angle side? It's where the side is. Is the side between the two angles or not? Okay. You'll be glad to know there is one more though. Hypotenuse leg. What kind of a triangle do we have? A hypotenuse and a leg? A right triangle. So this is a specific one that can be used for right triangles. It doesn't have to be, but it's an option. If it's not a right triangle, it's not an option. So fill in your notes. Hypotenuse leg, congruence, and I'm going to put right triangle needed. So you've got to have right angles. Which side's the hypotenuse of a right triangle?
Yeah. The leg across, well, the side across from the right angle.
Okay, side across from the right angle. That's the hypotenuse. And then you have to have the matching leg. So if it's the leg going up in this one, it has to be that same leg in the other one. Otherwise, they might match turned differently. Yes?
so you have to have those two?
You have to have a matching. Okay, if I made it this way and, I don't know, let's make it tall. Right angle, hypotenuse, hypotenuse. Let's say this side, which one would it be in the other triangle? Up. It's not the bottom necessarily, but it's the matching one. All right, so hypotenuse leg, could you use that in this diagram? Tristan, please pay attention.
You got both pictures back there.
They've been up there for quite a while. Okay, hypotenuse leg. First thing you have to check is, do you have right triangles? Right triangles? Yes. Okay, are their hypotenuses congruent? Yes, that's what I gave you. Do they have a pair of legs congruent? I see some yeses and some nos. Kenneth? Why? You knew I was going to ask that. Angle bisectors, not going to give you segments congruent. Is there a segment bisector? I don't see anything about a segment bisector. I thought you were going to give me reflexive property.
Yeah, I just did.
Oh,
Yeah.
okay, reflexive property. So if I would separate those triangles, that's the leg that's congruent in both of them. So hypotenuse leg does work there. Okay. How about, we'll look at just a few more pictures and then we'll start on the worksheet. Could this one be hypotenuse leg? You see two triangles on the ends of the picture? Okay. Are they right triangles? Yes. Are their hypotenuses congruent? It doesn't say. Can we come up with them?
Yeah.
With support? If you took out the space in the middle, that would make the slanted ones the same?
No, I mean, the 90 degree over the two dash
What would be the same?
the line.
This one would be the same as this one, or the ones that have the tick marks?
The one that had thick one.
Okay, the ones that have the tick marks are not the hypotenuses,
Oh, well,
they're the legs. So we have right angles and leg that would be congruent, but we're stuck on the hypotenuse part. Okay, so can't do it. Can't even do side angle side or anything on that one. That one just doesn't have enough information. How about this picture? Hypotenuse leg? Are they right triangles?
Yes.
Okay, how about legs or hypotenuses? Okay, Brendan's saying the middle one, reflexive, yeah. Is that the hypotenuse or the leg? That's a leg congruent in each one. Okay, she's saying, look at these angles. Our lesson yesterday, what kind of a big triangle is this? It has two angles congruent in it.
Hey, the breast.
So didn't we have a theorem yesterday that said there would be two sides congruent? And in this, wouldn't that be this side and this side? So we could use a theorem from yesterday, I think it was the converse of the isosceles triangle theorem, to get those sides congruent, and then we can say, yes, hypotenuse leg works. All right, I think that it's time for you to try some pictures. I think I probably have some more examples, but let's start on the worksheet. It is a worksheet. There, I put some book part to review for your quiz.
Hey, Miss Frank,
Yeah.
you ever collect bags?
Yes, you may.
Yeah.